So I'm going to record this. For the status bit, okay, when you have a ladder diagram like this, where you have a stop, a start, an output, we'll throw in a maintain here as well, okay? So the address is here. I have a stop in input 0, 0. So word 0, 0 at bit or input 0, 0, I have a stop push button. Then I have a start push button. The start push button is basically emulating or simulating this start push button, which is at address 0, 1. So 0, 0, dot 0, 1. Now, how do I know if the contact is open, if the contact is closed? Well, I'm programming the stop open and the start open. Why am I doing that? I have to look at several different things. My stop push button is normally closed. Therefore, the current goes through. If the current goes through, input 0, 0 is a logical 1. It's on, okay? A normally open push button, there is no current going through, so it's a logical 0. That input is off. When I scan or analyze this circuit, I have to consider what the status bit is. So, like I said, for 0, 0, it's a 1. For 0, 1, which is a start, it's a 0. Now, what I want to do is eventually turn on this output. Let's say the output, which is word 1, 0, is a motor. Okay. Now, what do I need to do to turn on the motor? Current's got to flow from the left all the way across through both of these conditions and activate the output. So what does this mean now? Well, if my status bit is a 1, the contact changes state. Since it's normally open and the status bit is 1, it changes from open to closed, which means that I have current flowing all the way to these two normally open contacts.
That's when you
so as soon as I power up, there is current going through this stop here, and it stops right here. I'm not touching a thing. I don't touch anything. It stays like this for the rest of its life until the next software update where it has to restart your computer. That was just a joke. So I have a start push button here. Nothing happens till I press it. When I press the start push button, the status bit changes from a 0 to a 1. Why? Because now there is current going through into input 0, 1. That's a 1. That's just for the status bit. If I'm analyzing the actual circuit or the ladder diagram, this software is basically looking into this memory location to see whether there's a 0 or a 1. There's a 1. If there's a 1, what happens to this contact, which I program normally open? It will change to normally closed. Now there's current going all the way through, activating this address, which is linked to an output, closing the contact on the output, but it's a logical 1. My maintain here, I'm maintaining with that same address. So this normally open contact also has a 1 as a status bit. And if that's a 1, this will also change state, which means that this guy here will stay closed. Now I'm still holding the start push button, but when I let go of the start push button, what happens? The status bit here and here goes back to 0. Why? There's no more current going through. I let go of my start. I have a 0. Therefore, I have a 0 here. If I have a 0 and I program it in normally open, well, it goes back to its initial state, which is open. Therefore, this is shown as, give me 1 second here. No current flowing through the start, okay? But because the maintain is still active, my output is still active here, okay? But this, when you see a symbol like this, it means that current is getting to the start. It's not going through. Why is it not going through? Because it's normally open. The status bit is 0, which means that it stays in its initial state. Now, the motor's on. You want to stop it. What do? You press the stop push button. What does that mean? I'm going to break the contact here. When I break the contact, there is no more current going to input 0, 0. So the status bit is a 0. If the status bit is a 0 and I programmed it normally open, it goes back to its initial state, which is open. If the initial state is open, there is no current going through this contact. Therefore, there is no current flowing through the circuit anywhere. This guy here is open. What happens when I let go of the push button? When I let go of the push button, it becomes a 1 again because there's current flow again. It's a 1. The status bit, this guy here as well, is also a 1, which means that a 1 means that the contact changes. If it's normally open, it changes to normally closed. Now I'm back to where I began, where the motor is off because I haven't pressed start yet, but there is current flowing through this guy here, this contact. Now my point here was I was using a reverse push button or a normally open push button. So if I were to use a normally open push button, what would happen? What would change? So the exact same template, if you will, okay? But now I'm going to change this guy here to a normally open. So I have 2 normally opens. I'll name this guy here reverse. I'll name this guy here forward. They're just push buttons that I'm naming reverse and forward. I can name them Vince and Vincenzo, but those are a bit too close. Molson and Vincent, okay? Doesn't matter, it's just a name. Right now, don't think of it as a motor having to go reverse and forward. Okay? It's just to analyze. So my status bit for my reverse push button right now is a 0. I have 2 normally open push buttons, 0 and 0. Now this would be my 0, 0.00, which is this input right here. We'll call it reverse. This guy here we'll call forward. And this forward is at this address, which is 00.01. I have an output, same as before, 10.00, which is my motor. Okay, I'll just put an M for now. And this is my maintain or my latch, whichever way you want to call it. Now, how does this one work? Well, if the status bit here is a 0, and the status bit here is a 0, what that means is that even if there's current present here on the left side of the contact, since the status bit is a 0, it stays open. There's no current going through here. So even if I press forward, it's not going to work. How do I get this to work? I have to change the logic of this contact and program it normally closed. Now, if I program this normally closed and the status bit is 0, 0 means that it stays as is, which is closed. And if it's closed, current will flow through this contact. And I basically have the exact same thing as I had here. Using a normally open contact, this reverse, as a stop, I could. Why can I replicate it? Because I'm programming. I can reverse the logic. This was a normally closed push button. I programmed normally open. This is a normally open push button that I'm using as a stop. So I have to program it normally closed. Okay, so let me continue again. If I press forward, what's going to happen? If I press my forward push button here, my status bit is a 1. My status bit here is a 1. I'll just erase this, make it a 1. Then what happens if it's a 1? It changes the state of this contact. If it changes the state of the contact, it means that it goes from open to closed. That closes the status bit of this address, which is the same address as the motor. Contactor coil gets activated. If I let go of the push button here, so let me just let go of the push button. Now it's an open. This guy here reverts back to 0. What happens when it reverts back to 0 is that this contact will no longer allow current to flow through. It goes back to being normally open. And I'm just going to redraw this contact in. And since we did not press stop, current is still flowing through here. Now, when I say stop, I mean what we're using as a stop, which is a reverse push button. This guy here. Keep in mind, it's a reverse push button. This is on now, right? But I'm using my reverse to stop. So what happens when I actually press this push button? When I press this push button, my status bit here is a 1. If my status bit here is a 1, all the contacts with that address will change state. So this status bit right here is now a 1. Let me erase the 0 and put in a 1. If the status bit is a 1, it changes the state of the contact. Since I programmed it normally closed, it changes it to open. It does not change the symbol here. That's, you programmed it as closed, it'll stay closed. How do you show that it's open? You remove the highlighted part. It will no longer be highlighted. So if this is no longer highlighted, no longer highlighted, no longer highlighted, no longer highlighted, I'll just go back to put what was erased. This guy here. So while the status bit here is a 1, this guy changes, which means that it's normally closed. It's now open, no current going through. If I let go of my reverse push button, it goes back to being normally open. It goes back to being normally open. That'll become a 0. This will become a 0. If there's zeros, this will go back to its initial state, which is closed. If it's closed, it means current gets through. I'm back to step number 1. So I can use a normally open and normally closed for the stop in programming. It's always ideal to use a normally closed push button because you continuously monitor the current flowing through the stop push button. But here we're just using programming to learn some skills to understand what's happening with the computer and the components. So I'm showing you what can be done. Okay.